All right, so moving right along to vector arrays. This is a combination of linear sequential and linear phased array technologies. All they did was they this is not this isn't necessarily I'm sorry, it's Saturday morning. This isn't necessarily a specific probe, but more of an addition or an upgrade or a kind of like adding to probes, because you can do it with the vascular and the small part transducers, but we don't call them vector arrays. We call what they can do virtual convex. So all we're doing is we're talking about an idea that instead of just having that rectangular shape, how do we see out to the sides? Like, how do we get wider than the linear sequential array transducers? How do we get outside of that rectangle that might be only 10 centimeters long? How do we see past that? So again, it's a combination of linear sequential and linear phased array technologies. They're rectangular strips of PZT material arranged side by side in a line, smaller footprint. The beam steering combines linear and phased array technologies, but some, not all, are fired simultaneously. This is where the beamformer kind of kicks in a little bit and does a little bit of extra work and gets creative. So if I have these groups of crystals arranged on my transducer, okay, and they're all lined up as such, and normally I would fire straight down the line, right? But I'm now telling, let's just draw some extra groups here, these to fire here, these to fire here, these to fire here, and then the last ones steer out this way, and you see now the image shape that I get. Not really, there you go. So I went out to the side here, straight down, out to the side here. I just use my outer crystals, my outer groups of crystals, to cover out a wider area. Beam focusing is electronic. It also uses dynamic receive focusing. The image shape is trapezoidal. Again, this is why. Because I am no longer steering straight down. I'm steering out to the side and steering out to the side, and I get a wider arrangement or a wider image on both sides of the rectangle, hence trapezoidal. That's the question I'm going to ask you. Vector array transducers create what shape image? Trapezoidal. Beam focusing is electronic. What is the what's the advantage of using linear sequential, or what is the advantage of using a vector array? I don't even know how I would ask. It's just so straightforward. You can see beyond. Nah, scratch that. You can. Oh, I lost my train of thought. Poopy. And yes, I just said poopy. The advantage of vector arrays are that we get a wider field of view. That's what I was trying to say. But I'm going to ask you more specific to as if it were its own transducer. You get the gist of it, if you will. Forgive me. I just turned this thing on and started talking, so I didn't really have a plan. So please forgive my incompetence right now. Again, so no table 12.3 and 12.4 on page 185. That is, again, the ultrasound religion, if you will. It's a large part of the registry. And the way the chart is set up, that's how you need to know it. You need to know mechanical transducer has a sector shape image. The steering is mechanical. The focusing is fixed, and so on and so forth. Linear. Remember, linear switched is just linear sequential. They just use switch because it's a fancy word. But linear sequential, switched, whatever you want to call it. And then above that 12-3 transducer type, they give you the probe or the transducer, and then they ask you what's the effect on the image. Just if you understand that, you can answer any question that I put in front of you and the registry puts in front of you. It's that simple. All right. So I am going to stop here and then start over. That's just a quick video to end the other one, and then since this is a whole nother topic, I'm gonna stop there.